So we continue with the light energy, and we had done up till now the refraction and also the uh, consequences of the reflection, that is early sunrise and late sunset, mirage in the desert. So that was a part which we studied earlier. Now we will see that how the reflection of light would take place when it is going from in a rectangular block. Okay, so if I got a rectangular block, then how is the light going to travel through this rectangular block, and what are the different places where the refraction is going to take place? So what is a rectangular block? It is just a simple, this is a rectangular block. Now we are not going to draw a three-dimensional figure. We are just going to consider that the upper surface is where the ray of light, that is the incident ray, is going to fall on this particular place like this. So if I see the figure, I know that this part is air. It's a rectangular glass, so this is glass. Similarly, this is glass and this is air, right? This is my incident ray, and this incident ray is falling at this particular point of incidence. So if I draw a perpendicular over here, this is my normal. So this is the normal. Now, as per this line should have gone like this if there is no deflection, right? If there is no reflection taking place, then this line would have gone like this. But now I know that it is going from a rarer medium to denser medium. Now when I know that rarer medium to denser medium, it goes towards the normal. So instead of going like this, it is going to go towards the normal, that it is going to go like this. Okay, so because it is going from a rarer medium to denser medium, that's why it is going to go towards the normal. So this is what is going to happen over here. So accordingly, if I want to mark the different angles which are here, so I know that this angle is I, this angle is R. Angle of refraction, the angle of incidence. Okay. Now, as the light passes, so now inside this glass, because the medium is not changing, so the speed of the light inside the glass will remain the same, and hence there would not be any change in the path when it is traveling through that particular glass slab. So within the glass slab, the line will be going straight. It is only at the surface that this bending takes place. We know that refraction is a surface phenomena, so it is going to be only on the surface. एक बार वो surface cross कर दिया, वो दूसरे medium में पहुंच गया, उसके बाद there would not be any refraction, there would not be any change in the path. The change of path will be initiated only when it is changing the medium. Accordingly, you can see that this incident ray, which was supposed to go like this when a dotted path, but it is going to go this way. Now it reaches this point, that is the other point over here. So again, this becomes my incident ray, and this over here is the normal. So if this is the normal, so now I know that this is a denser medium. This was rarer, this is denser, this denser, this is rarer. So I know that denser to rarer, मालूम है ना Dr. A, right? या Dracula, जो भी तो DRA. So denser to rarer, it is going to go away from the normal. So instead of going in this manner, the straight line going like this, it is going to go away from the normal like this. Now, so this angle which is formed with the normal over here, this angle is called as the emergent angle, angle of emergence, and this ray is called as the emergent ray. Okay, it is the emergent ray, and this is the angle of emergence. Now, over here, it will be seen that if I extend this line over here, it will be seen that this line and this line over here will be parallel to each other. Okay, that means what has happened is that the ray of light, it has got deviated twice. There is a twice the refraction taking place. One is towards the normal and again away from the normal. So in this way, the pathway almost remained the same, except for the fact that there was a lateral displacement which has taken place. Okay, this thing जो ऐसे जाने वाला था उसके बदले ऐसे जा रहा है, but ये दोनों parallel है. So the direction is the same, but they are parallel lines, that because they are called as a lateral. So it is called, this particular distance which is over here is called as lateral displacement. This is just an extra information to you which you will be studying in the 10th standard, but anyways you can just note this thing that this is called as lateral displacement. So let's read out this particular part from the textbook. Refraction of light through a rectangular glass block. Figure 5.11 shows a rectangular glass block PQRS. A light ray AB falls on the surface PQ. So they are given you that this is AB which is falling on this particular line which is PQ, and this is RS. Okay, so PQRS. At the surface PQ, the ray AB enters the air to glass, so it bends towards a normal NBM. So that is, this is N, this is B, and this is M. Okay, and travels through BC. At the surface RS, another refraction occurs N dash C M dash is the normal at the point of incidence at RS. So there, this one is N dash C M dash. Okay. The ray BC now enters the glass to air, so it bends away from the normal, and hence, ये normal say it is going to go away from the normal along the line along CD. The ray AB is called as the incident ray, BC is the refracted ray, and CD is the emergent ray. The emergent ray CD is parallel to the incident ray AB. So the emergent ray CD is parallel to the incident ray AB. This is the important part over here. Thus both the incident ray and the emergent ray are in the same direction, but the emergent ray is laterally displaced. Okay, this is the word, laterally displaced. So the emergent ray is laterally displaced from the incident ray. In figure 5.11, the lateral displacement is shown by CE x, which is perpendicular distance between the incident ray and the emergent ray. So this is x what we are talking about. So this is the lateral displacement. This distance over here, x, is the lateral displacement what we are talking about. The next one we see is a prism. Okay, so this was about the light ray passing through a glass block. Now we are going to see that what would happen if the same light ray is not passing through a glass slab, but it is passing through a prism. Now what is a prism? So first of all, let's understand what is a prism. Prism is a triangular kind of a cylinder. What is a triangular cylinder? Because it is like this. This is a base, and then if you extend it like this backwards, I mean like this, so it is going to be, so this over here, so this is a prism. Okay, triangle ऊपर, triangle नीचे, और सब lights तीन sides बनाएंगे, तो almost like a pyramid as such, but not a pyramid. Pyramid is slightly different. Here it is a prism, so a cylindrical block. Or if I want to show it, I can easily show it by a piece of paper. Like if I take it this way, one second, I'll show you. So if I make it like this, okay, I just join this like this. So this is a triangle. There is a triangle over here, and this thing. So this particular thing over here, this is a prism. Okay, this is a prism, which is going to be triangular shape, triangle like this. Okay, this is a triangular pipe, you can say. So this is a prism. Okay, this is exactly what the prism looks like. Okay, so of course it is made up of glass, so that light can pass through it. So this is a prism. Now in this prism you will find that the surface over here, this one, that is this complete surface over here, and this one are the refracting surfaces, or the one in the incident surface wherein the light is going to fall on. So a prism is a transparent medium bounded by 5 plane surfaces with a triangular cross section. So 5 plane surfaces, with the 5 plane surfaces, 1, 2, 3, and then triangle over here and triangle over here. So 2 bays which are triangle, and 1, 2, 3 are the 3 rectangles which are forming the other 3 sides. So accordingly it is a 5 one which 2 opposite sides are being triangles. 2 opposite surfaces of the prism are identical and parallel triangles, while the other 3 surfaces are rectangular and inclined to each other, as shown in the figure 5.12. In symbol form, it is represented by a triangle ABC. So in a symbol form, we are not going to consider these lines at all. We are just going to consider that this is just a triangle. So we are considering the prism to be as just a single triangle. I'll just show it once again. So the prism is symbolically represented by just a simple triangle ABC. Now, how is the refraction going to take place in a prism? So suppose there is a ray of light which is going to come over here like this. So it is falling on this particular plane like this. So this is the incident ray. So this is the incident ray. Now this is the point of incidence, so there will be a normal to be drawn over here. So the normal can be drawn over here, which is be perpendicular to this side. So this is the normal which can be drawn. Okay, so we'll call this as O, this is N and this is M, right? Now this incident ray, when it is entering here, so what should happen? This line should have traveled in this manner, in a straight manner, but because it is traveling from a rarer medium to denser medium, so rarer to medium, denser medium, it is going to be towards the normal. So instead of going here, it is going to go towards the normal, hence it is going to come over here like this. Okay, so this line over here is the refracted ray. Of course, this is the angle of incidence and this is the angle of refraction. Is it clear? So the incident ray, it did not go straight, but it bent towards the normal and hence it is passing through like this. On reaching this point, we can draw another normal over here because this becomes the incident ray now, and we have got another normal which can be drawn over here like this, which will be N dash O P M dash. Okay, it's R M dash. So this particular line, you can see that this one should have gone directly this way, but it is going to refract, and here it is the denser medium and this is the rarer medium. So rarer to denser was towards the normal, denser to rarer is away from the normal. So instead of going over here towards the normal, it will go away from the normal and hence it is going to travel like this. So this over here is the emergent ray. Okay, this line over here is the emergent ray, and of course this angle over here which it is making with the normal will be the angle of emergence. E is the angle of emergence. Is it clear? So it is seen that whenever the ray of light, so here you can see that a ray of light was traveling in this manner. When it enters into the prism, it also changes a very huge amount of refraction and causes to go like this. Okay, जो इस तरह से जा रहा था वो पूरा टर्न होके sorry, instead of going like this, it is going to turn like this. So this is what happens when there is a refraction taking place by a prism. So that's the refraction about the prism. So let's see what is given in the textbook. Refraction of light through a prism. Figure 5.13 shows a prism ABC. A ray of light PQ of single color falls obliquely on the face AB of the prism. The ray enters from air to glass, from rarer medium to denser medium. So it bends towards the normal NQM to the face AB. So it goes towards the normal, towards the bends to, towards the swing, and hence it is going to go straight like this. At the face AC of the prism, another refraction occurs. The ray QR now enters from glass to air, and hence there will be the refraction is going to be away from the normal. So from denser medium to rarer medium, so it bends away from the normal N dash RM to face AC and travel along RS. Thus, for the incident ray PQ, the refracted ray inside the prism is QR and the emergent ray outside the prism is RS. So this was PQ, QR and RS. Okay, so this is the emergent ray and this is the incident ray. Thus on passing through a prism, the light ray bends towards the base of the prism. So here is the final verdict. What is the verdict? That whenever the ray of light is passing through a prism, it is bending towards the base. तो वो जा रहा था away from the base, but बाद में जाएगा towards the base. Now, do you know? The emergent ray through a prism is not in direction of the incident ray, but it bends towards the base of the prism because in a prism refraction occurs at two inclined surfaces. See, in case of the glass slab, they were not inclined, they were parallel surfaces. Because they were parallel surfaces, so even the emergent ray and the incident ray were parallel to each other. So the direction of the propagation of the light ray was not changing, it was remaining the same, it was just displaced parallelly. Okay, but over here, because there are two inclined surfaces, hence what is happening is that the original ray of light ka direction is completely different from the previous one. There is completely then the emergent ray. And you see that on the other hand, in rectangular glass block, refraction of light occurs in two parallel surfaces. So the emergent ray is in the direction of the incident ray but laterally displaced. So this is something important between the, or you can say differentiation between the glass slab, refraction in a glass slab and refraction in a glass prism. In case of a glass prism, the emergent ray is not in the same direction as that of the incident ray, whereas in case of the glass slab, the incident ray and the emergent ray are in the same direction, only with a slight lateral displacement. Now, whatever we did over here was considering that the light ray, now if you can see, if you read the paragraph properly, it is given that a ray of light enters. Now this is of a single color. They are given that PQ, light PQ is made up of a single color. Okay. It is seen that the sun rays are not of single color. They are made up of 7 different colors. We know that. That's what we see in the rainbow. Vibgyor, okay, we know very well that the sun rays are made up of these are the 7 colors: violet, indigo, blue, green, yellow, orange, red. Okay, so the sun rays are made up of 7 colors. Now if I am taking a single color, then the refraction through a prism is going to be this way. Okay, the prism ka jo refraction hai, that is going to be in this manner when it is a single color. But if it is not a single color, then what is going to happen is each and every color will have different angle of deviation. Okay, see, you can see the light is getting deviated. जो ऐसे जाने वाला था वो भी bend होके ऐसे गया. But what happens is all the 7 colors do not have the same angle with which they bend towards the base. In case of a prism, whenever the ray of light passes through the prism, depending upon the color of the light which is passing through, the angle through which it is going to get deviated is going to be different. That's the reason when I am taking a light ray which is a polychromatic light ray. Now polychromatic means a light ray which is made up of 7 colors, or we can say the light ray which is the sunlight. If such a thing happens, so if I am taking a white light, so this is a white light. Here what will happen is, first of all, as soon as this enters into this particular prism, the light is going to refract at different angles. Okay, the light is not going to refract together. If it is refracting together, then it will remain white only. But here what happens is, the refraction is different for different colors of the light. And due to this, the 7 colors which are present inside this white light are going to deviate in a manner in which they are going to separate out, and hence what happens is it is going to deviate with like this, wherein there will be 7 colors. So the red is over here and the violet is over here. Okay, so violet, indigo, blue, green, yellow, orange, red इस तरह से आएगा. And then over here again there will be a refraction. So it is going to go towards the base. So it goes towards the base like this, like this, like this, like this, like this, like this, and like this. So if I put a screen over here, you will find that on the screen you will see the 7 colors of VIII, that is nothing but violet, indigo, blue, green, yellow, orange, red. So you will be seeing a rainbow sort of thing on the screen when the ray of light, which is a white light made up of 7 colors, that is nothing but the sunlight, when it is passing through this particular prism, all these 7 colors are going to have different deviations. They are going to deviate differently, they are going to refract differently. So the one which is violet will refract the most, hence it is going to become bent a bit more, whereas red is going to deviate the least. Accordingly you will find that violet से लेकर blue red तक का पूरा एक spectrum बनेगा, that is called as the spectrum of light. Now this was also done by Newton's disc. So if you remember, there was one particular in the previous class, you had got one disc. You had take a small round disc and you color violet, indigo, blue, green, yellow, orange, red on that particular disc, and then if you put it on a divider and rotate it, you will find when you rotate it, all the 7 colors, when it rotates, you will get mixed up and you will be able to see the disc to be only a white color. It doesn't give you the 7 different colors, it gives you a white color. Why is that so? It's because all the 7 colors merge together to give you white color. Okay, so that's basically the Newton's disc. So Newton allowed white light from the sun to enter a dark room through a small aperture in the window and placed the glass prism on in the path of light ray. The light coming out of the prism was received on a white screen. On the screen, a colored patch like a rainbow was found as shown in figure 5.14. This patch was termed as spectrum. Okay, so it was an accidental thing that accidentally Newton जब भी एक जगह पे काम कर रहा था तो one of the window pane just broke and the sun rays started entering into it, and the window pane was cut in such a way that the glass was slightly in a slant manner. So when the light ray fall on that particular glass cut, it gave on the floor it gave us 7 colors. So Newton was very curious about this particular thing, and he found that if you take a prism and allow the light to pass through them, then it is going to split into 7 colors and you're going to see the 7 colors over there. So starting from the side of the base of the prism, the color of the spectrum on the screen are shown in the following order, that is VIII, that is violet, indigo, blue, green, yellow, orange, red. Violet, indigo, blue, green, yellow, orange, red. The order of color of the spectrum can easily be remembered by the word VIII. Thus, spectrum is a colored band obtained on a screen on passing the white light through a prism. So we can define spectrum as the colored band obtained on a screen on passing the white light through a prism. From the above experiment, Newton concluded that white light is mixture of 7 colors. Note that the prism does not produce color, but it simply separates a color which already exists in the white light. So this he further also did one more thing, and that is instead of taking a white light, he just took a green light and he tried doing the same thing. He found that the green light did not convert into another 7 colors. So it was understood that it was not the prism which was generating the 7 colors, it was just the white light which was already having 7 colors in it, but was all together. So as soon as you are passing it through a prism, because of the different angles of refraction, what you are getting of the different colors of this particular of the light, that's the reason the light rays are separating out from each other and you are getting a band or a spectrum of colors. Thus, if white light is passed through a prism, it splits into different colors. This is called as dispersion of light. So the definition of dispersion will be that if white light is passed through a prism, it splits into different colors. This is dispersion of light. So what is the cause of the dispersion? Again, in class 7 you have read that white light of the sun is composed of 7 prominent colors, namely violet, indigo, blue, green, yellow, orange, red. The speed of the light of all colors is same in air and vacuum, but it differs in transparent medium such as glass or water. In a transparent medium such as glass or water, the speed of violet light is minimum and the red light is maximum. Therefore, the refractive index mu of the transparent medium is also different for lights of different colors. So what exactly do you mean is that we know that what is the refractive index. We studied in our previous video that refractive index mu is equals to speed of light in medium 1 upon speed of light in medium 2. Medium 2, right? So now if I know that speed of light of different colors are going to be different, accordingly what we'll find is that the speed of light for violet is going to be less, whereas that of red is going to be more. Accordingly, जिसका speed ज़्यादा उसका refraction कम. Okay, so the refractive index of red is less, whereas the refractive index of the violet is more. Thus, the violet color deviates more. So violet color यहाँ से पूरा का पूरा bend होके इधर जाता है, red color सिर्फ इतना ही bend हुआ. So since the refractive index is the speed of light in air upon speed of light in medium, the refractive index of the medium is maximum for violet light and minimum for red light. So the refractive index is minimum for red light and hence it deviates the least, and it is maximum for the violet light and it deviates the most. Therefore, when the white light enters the prism, it splits into its constituent colors, while refraction at the first surface of the prism, these colors get further separated from each other on refraction on the second surface of the prism. So first, there is already this particular refraction causing the change in the pathway of each and every 7 colors, and further when it is reflecting once again, the splitting is increased. So this gives rise to the complete formation of the spectrum or the dispersion of light. Do you know, in rainy season, sometimes after rains, you see a rainbow in the sky. Just opposite to the sun, it is due to the dispersion of white light of the sun by the raindrops, which behave like a small prisms. So you will find that many times in the evening time during the rainy season, you see a rainbow in the sky. And when you see the rainbow in the sky, you will find that okay, there is a sun on the other side of the rainbow. So the sun, actually what happens is that there are in the clouds or in the air, there are too many water droplets. So these water droplets, you can see the water droplet. So water droplet is shaped like this. Okay, this is the shape of the water droplet. So if I see this part over here acts as a prism, so the ray of light which is falling over here is going to form a prism over the refraction over here, and that is the dispersion over here. So accordingly, the droplets of the water which are present in the air, they are going to act as a prism and hence cause the rainbow to be formed in the sky. So the dispersion light can be demonstrated by the following activity. So you are just taking a thick cardboard, make a small hole in it, allow the sunlight to pass through it in a dark room, place the prism in the path of the sunlight coming through the hole, and then a white screen behind the prism is shown. So you are placing a white screen over here, you are allowing the light to pass through over here and fall in the prism, and you will see a band of colors obtained on the screen with colors violet, indigo, blue, green, yellow, orange, red in order from the base of the prism upwards as shown in the figure 8.15. And also we can see the activity 4, which is nothing but the Newton's disc. So take a circular disc of cardboard and divide it into 7 sectors. Then paint the sectors with 7 colors, violet, indigo, blue, green, yellow, orange, red in order as shown in the figure, and then rotate this disc rapidly. You will notice that the disc appears white. This shows that 7 colors, violet, indigo, blue, green, yellow, orange, red, being the constituent of the white color, when combined produce a white color effect. So this is the concept of the formation of the rainbow, also the concept for different color formation being taking place whenever there is white light, or the dispersion of light, or the spectrum of the light being formed. So we now to continue with the next part of the chapter, that is based on spherical mirrors. Okay, but I think I'll continue it in the next video so that the proper formation.